Pre-calculus, this is the review for the quiz covering 5.1 and 5.3. The first one on the review wants us to verify an identity. Remember, we typically like to go with the more complicated side, which is definitely the left side. I'm going to turn everything into sines and cosines. So cotangent is cosine over sine. Secant is 1 over cosine. And cosecant is 1 over sine. I realize the secant and cosecant were being multiplied. So those will get put together. I'm going to end up with cosine x over sine x minus 1 over cosine times sine. So I've got two fractions that do not have common denominators. I'm going to go ahead and get common denominators so I can put them together. Basically, the common denominator will be cosine times sine. Basically, this is the common denominator here. So the first fraction needs a cosine. So I'm going to multiply top and bottom by cosine. So this is going to give me cosine squared over cosine times sine minus 1 over cosine sine. Now that I have this same denominator, common denominators, I can combine it into one single fraction. So this is going to be cosine squared minus 1 over cosine times sine. Now here's where the real hitch comes in on this. Cosine squared minus 1 actually is a version of a Pythagorean identity. This would be off to the side. We know that sine squared plus cosine squared is 1. If I rearrange this formula to get cosine squared minus 1, I would subtract this 1 over, and that would have to mean that I'm also going to have to subtract the sine squared to the other side. So what I'd end up with is cosine squared minus 1 equals negative sine squared. So I can replace cosine squared minus 1 with negative sine squared. So I've got negative sine squared over cosine times sine. That was a variant of a Pythagorean identity. Now I can reduce down the common factors. There's sine squared on top, there's sine on bottom. So one of them on top can reduce with the one on bottom. That would leave me with negative sine over cosine. Sine over cosine is tangent. So this is negative tangent, and we're good. For the second one, we're looking at double angle stuff. So we're told what quadrant we're in, and we're given one of the trig functions. This pretty much always means let's draw ourselves a triangle in that quadrant. So I'm going to be in the second quadrant, build a right triangle to the x-axis. Remember, my reference angle is the angle I'll be doing my trig from. I'm being told the tangent. Remember, tangent is opposite over adjacent. So this means the opposite is 15, the adjacent is 8. If you do some Pythagorean theorem on this, you will get that the hypotenuse is 17. So I can find any trig value I want. I'm trying to find first the sine of 2x now, using the identity. Remember, it's not just double the sine, it's 2 times the sine of x times the cosine of x. Looking at my triangle, the sine from the reference angle is opposite over hypotenuse, and sine is positive in the second quadrant, so that's positive 15 over 17. The cosine is negative in this quadrant, and it would be 8 over 17. Then just multiply together, so across the top, 2 times 5, I'm sorry, times 15, times negative 8. So I'd have negative 240. On the bottom, 17 times 17 is 289. That does not reduce. That's my answer. For the cosine of 2x, remember we really had 3 different versions. You can use any one you want. I usually just stick with the first one, cosine squared minus sine squared. So cosine, I already did that. That was negative 8/17 squared. Minus the sine, I already did that. It was 15 over 17 squared. Recall, I'm squaring a negative, so it's going to become positive. But on the second one, I'm squaring a positive, but I'm still subtracting. So the first one's going to become 64 over 289 minus 225 over 289. I've got common denominators. If I subtract across the top, I end up with negative 161 over 289. For the tangent, remember there was an identity, but you don't have to use the identity since I already have the sine and cosine. I can just take the sine, negative 240 over 289. I'm going to divide by the cosine, but that means multiply by the reciprocal, multiply by negative 289 over 161. Let's make a little line. Oops, that's not at all what I wanted. Make a little line here. Let's see what problems what. There we go. The 289s cancel. Negative times a negative is positive. And it's 240 over 161. For the third one, we want to use a half angle formula to find the sine of 165. So I'm basically telling you, hey, 165 is half of a nice angle that we know. Well, to figure out what that angle is, you would just take 165, 5, and double it, which is 330. So now I can apply the half angle formula for sine. Remember, there's that plus or minus out in front. I have to look at the actual angle. I'm doing 165, which is in the second quadrant. Sine is positive in the second quadrant. So this is going to be positive square root 1 minus the cosine of the x, which is the 330, all over 2. The cosine of 330, just as a reminder, 330 would be over here with a 30-degree reference. Which makes my adjacent, which is the cosine, root 3 over 2. And all students take calculus. Cosine is positive in this quadrant, so it's positive root 3 over 2. But realize that the problem, the formula itself, or the identity, had the negative sign. So basically, the negative will stay there. This is all over 2. Now, similar to what I've done in the notes for this, there's several ways you can attack this from here. I'm going to basically divide that 2 into both. So this would be square root of 1/2. Divide the 2 into the root 3 over 2, which is going to make it root 3 over 4. So common denominators, this would be 2 fourths. So that's going to be 2 minus root 3 all over 4. And the last thing I can do is I can take the square root of the numerator and denominator. And that would give me root 2 minus root 3. On the bottom, the square root of 4 is 2. And there's my final answer. For the last problem, we're doing half angle stuff again. This time we're finding the sine, cosine, and tangent of a half angle. And again, we have a weird trig function, 40 over 41, and we're told what quadrant we're in. So I'm in quadrant 1, so draw yourself some random right triangle in the first quadrant, not drawn to scale. The sine, so opposite over hypotenuse, is 40 over 41. If you do some Pythagorean theorem, you'll get your adjacent to be 9. And so now we're ready to roll. So same formula that we just did. Sine theta over 2. Now remember, again, the sign, S-I-G-N, the plus or the minus, is based off of what quadrant this angle is in. Well, if theta is in the first quadrant, slicing it in half, it's still in the first quadrant. So it's definitely in the first quadrant. So basically the sine and the cosine are going to both be positive. It's going to be square root of 1 minus the cosine. The cosine on my triangle would be 9 over 41 all over 2. Just like I did on the previous problem, I'm going to split this into 2. So this will be 1/2 minus 9 over 82. Common denominators of 82 would turn the 1/2 into 41 over 82. That's going to turn this into the square root of 32 over 82. That does reduce, and it's convenient. If I reduce it by 2, I end up with 16 over 41. Square root of 16 is 4. Square root of 41, I can't do anything with. But there's my sine. Cosine will follow very similarly. It's almost the same formula, except that it's 1 plus the cosine. So it's be 1 plus 9 over 41 all over 2. I'm not going to go through every step, but you'd be following the exact same procedure that we did for the sine. You should end up with square root of 50 over 82, which reduces to the square root of 25 over 41, which is 5 over root 41. And for the tangent, again, you can use the identity, but we can just take the sine over the cosine. So the sine was 4 over root 41. If I'm dividing by the cosine, I'm multiplying by its reciprocal, root 41 over 5. Root 41's cancel. And we're just left with 4/5. Oops. Press something there. Oh, made a big old mess. Hold on. There we go. 4/5 for the tangent. Okay, your quiz will look similar to this. A few more problems on it, but similar to stuff you've seen on this and your homework.